I'm Kirsty and I study neutrinos at Fermilab. You may have heard me say that almost everything makes neutrinos, even bananas. And I'm not the first person to use this example. So why do bananas make neutrinos? That's what we're going to talk about today on Even Bananas. To understand where the neutrinos in bananas come from, we need to talk about radioactive decay. Specifically, we need to talk about a type called beta decay. We actually talked about beta decay in our first episode, and forgetting the complex terminology, it's just a process when one element turns into another one. How? Well, inside an unstable nucleus, a neutron can become a proton, an electron, and, you may have guessed, a neutrino. Beta decay happens to lots of different elements, and in fact, almost all of the neutrinos that are produced on Earth come from beta decay. Now, bananas, as you might know, contain a lot of potassium. And that's great. Potassium is an essential mineral used in all sorts of biological processes. Potassium actually exists in three main isotopes, with the same number of protons but different numbers of neutrons. Potassium 39, 40, and 41. Potassium 39 and 41 are stable, but potassium 40 is unstable and undergoes, you might have guessed, beta decay. Although actually it doesn't decay very quickly. If you took a lump of potassium 40 and waited 1 billion years, a bit less than half of it would have decayed. About 0.01% of potassium occurring naturally in the universe is potassium 40, and that includes the potassium in bananas. An average sized banana contains about 450 milligrams of potassium, and of that amount, about 0.5 milligram is the radioactive version, potassium 40. That amount, about the mass of a single grain of sugar, translates to about 1.2 million beta decays per day, and each one of those beta decays produces a neutrino. So the banana in your kitchen is producing over 1 million neutrinos per day. And bananas are hardly the only food that neglects to list neutrinos on their nutrition label. Other foods that are rich in potassium, like potatoes, avocados, beans, tomatoes, and milk, produce neutrinos too. That may make it sound like your kitchen is bursting at the seams with neutrinos, but it's really not. In fact, your own body makes way more neutrinos than anything in your pantry. A typical adult has as much potassium in their bodies as several hundred bananas. So as you work, eat, and sleep every day, you're emitting hundreds of millions of neutrinos. It's quite the hidden talent. But all of that pales in comparison to the biggest emitter of neutrinos in our lives, the sun. As many as 100 billion neutrinos from the sun pass through your thumbnail every second. That makes the neutrinos from your banana look more like a rounding error. So then, what happens to all these neutrinos? Mostly they just fly through Earth and into space without leaving a trace. Remember, neutrinos really don't like to interact with other matter. In fact, if for some reason you had a banana right in front of you all the time forever, you would still need to wait about 2 billion years before a neutrino from it interacted with your body. And by that point, it wouldn't really be a banana anymore. So the bottom line is that neutrinos are produced all the time by everyday objects. Bananas are just an especially good example. All this talk of bananas is making me hungry. Do we need these for anything else? Cool. Fun fact. If the sun was replaced by a bunch of bananas with the same volume, then 40,000 neutrinos would reach us per square centimetre per second. Not bad for a humble fruit, although it's still 2.5 million times smaller than the actual neutrino output of the sun. Tasty neutrinos. Oh, one more fun fact. Bananas are often used to define an informal unit of radiation called the banana equivalent dose. On a typical day, you pick up about 100 banana equivalent doses of radiation from your natural environment. An X-ray at the dentist's office would be about 50 banana equivalent doses. So eating one banana really doesn't make much of a difference.